So good afternoon, everyone. In this session today, we'll be discussing previous year questions, PYQs of alternating current, right? So we'll be discussing some of the important questions as well as PYQs of alternating current for your upcoming NEET exam, right? So let's begin with the question number one here, right? The question number one here on the screen is that find the time taken by the current to reach I naught by root 2 if the frequency of the given current is 50 hertz, right? So the question is like this. Let's suppose since it's a, question based on AC, right? So the frequency of the AC is given as 50 hertz, right? So the question is that let's suppose we have been given a current I is equal to I naught sine of omega t, right? Sine of omega t. We have to find the time at which the current will become I naught by root 2, right? So what we'll do here is just substitute the value of I here. That will be I naught by root 2. That will be equal to I naught sine of omega t, right? Omega t. From here, I naught and I naught will get cancelled. We'll be left with 1 upon root 2, and that will be equal to sine of omega t, right? Sine of omega t. Now we know that 1 by root 2 is the value of sine of 45 degree, right? It means that the value of omega t must be here equal to pi upon 4, right? That's equal to 45 degree, right? So from here, the time after which the current will become I naught by root 2 will be given by pi upon 4 times omega, right? And omega is nothing, it's 2 pi times the frequency, right? So we can write omega as 2 pi times the frequency. So the frequency here is given as 50 hertz. From here, pi and pi will get cancelled, right? So it will be 1 upon 400 seconds, right? So this much time, it's a very small time, right? After which the current will become I naught by root 2, right? So this is how we can use the equation of the AC current to find out the different parameters, right? Here omega is nothing. Omega here is angular frequency, right? Omega is nothing. It's angular frequency. Now let's move to the question number second. The question number second is that if an AC main supply is given to be 220 volts, what would be the average EMF during a positive half cycle, right? So the question is that let's suppose we have been given an AC, right? The AC is a sine function, right? It's a sinusoidal AC, right? So it's a function of sine, right? So let's suppose this is the AC supplied, right? Or we can write this as V is equal to V naught sine of omega t, right? So this is the supplied AC, input AC, right? So this is the input AC, right? As a function of time. So there are two cycles. One is the positive half of the cycle and another is the negative half of the cycle, right? So the time taken to complete the one complete cycle, that's what we call as time period, capital T. And for half the cycle, it will take half of the time period, right? So this is the time period of this AC cycle, right? The question is that if an AC main supply is given to be 220 volts, right? So 220 volts is the AC main supply. So it means that whenever we say that 220 volt is the AC main supply, this 220 volt is nothing. It's actually the RMS value, right? It's nothing. It's actually the RMS value, right? We know that AC has always a variable voltage at different times, right? So the voltage changes at each and every instant. So whenever we talk about this fixed voltage here, right? This fixed voltage is actually RMS value of the AC supply, right? So we have to calculate the average EMF during a positive half cycle, right? So what we'll do here, we know that average of any function, we how we can calculate the average of any function that's represented by this symbol. So we'll integrate the function with respect to the variable. Here the variable is time. We'll integrate the voltage with respect to the time, right? And divided by integral of dt with the proper limit. So for positive half of the cycle, the time taken will be the half of the time period. So we'll integrate it between 0 to half of the time period. So 0 to half of the time period, right? Now you can see here the V is equal to V naught sine of omega t, right? dt with limits 0 to t by 2. It's the half of the time period upon integral of dt with limits 0 to t by 2, right? So from here, now integrating it, so V naught will be outside the integration of sine of omega t, it will be minus cos of omega t, right? Divided by omega, right? So it will be minus cos of omega t and divided by omega, right? So this will be the integration of this term, right? With the limit 0 to t by 2, right? Upon t by 2, right? Upon t by 2. From here, the average value of the voltage or the EMF for the positive half cycle, it will be, we'll substitute the upper limit and the lower limit. So upper limit here is t by 2, right? So omega we can write it as 2 pi by t. So substituting the upper limit t by 2, right? So it will be cos of pi, right? Cos of pi. Let me do it in this way. Cos of omega we can write it as 2 pi upon t multiplied by the limit, that's t by 2. So from here t and t will get cancelled, 2 and 2 will get cancelled, we'll be left with only cos of pi, right? And cos of pi is nothing, it's minus 1, right? Cos of pi is, we'll just take this negative sign outside, it will be cos of pi minus cos of 0, right? Cos of 0 upon half of the time period, that's t upon 2, right? So from here, cos of pi is minus 1 and cos of 0 is 1. So minus 1 and minus 1, it will be minus 2 multiplied by negative sign, it will be plus 2. So it will be 2 V naught upon omega, right? Into t and multiplied by this factor 2 here, right? So the average value will be 4 V naught, 4 V naught omega, right? Multiply omega, we can write it as 2 pi upon the t multiplied the time period t. So this t and t will get cancelled. This 2 and 2 will get cancelled. We'll be left with the average value of this positive half of the cycle as 2 V naught upon pi. So it means that the average value of this EMF for the positive half of the cycle will be nothing. It will be 2 V naught upon pi, right? 2 V naught upon pi, right? Now, a V naught is nothing. It's the peak value, right? V naught is nothing. It's the peak value. V naught is nothing. It's the peak value, right? V naught here is peak value of the given EMF, right? It's the peak value of given EMF, right? We know that the RMS value is nothing. RMS value is nothing. It's the peak value upon the root 2, right? Root 2. Or we can replace the peak value V naught with root 2 times VRMS, right? And VRMS is given here. That's equal to 220 volts, right? 220, right? So we can replace it with this. So it will be 440 root 2 upon pi. So this much will be the actual answer for this question for the average EMF during a positive half cycle, right? So this is how we can calculate the average for any function or for be it current, be it voltage, or be it any other physical quantity, right? Now let's move on to the next question. The question is finding the RMS values, right? RMS values. Now you can see here we have been given a current as a function of time. The current as a function of time is given as 3 plus 4 sine of omega t plus pi by 3. So this is the current as a function of time. We have to find the RMS value for the given. We have to find the RMS value for the given current, right? Now, in order to find the RMS value, we can just do it in this way, in the reverse direction. That's square, mean, and root, right? Square, mean, and root. So it means that we will just first square the function and then take the mean of that square, and after putting the root on that mean square will give us the RMS value, right? Let's see one by one how we can calculate the RMS value of any function, right? Here we have to calculate the RMS value of this given current. So first of all, what we'll do here is that we will just square this function. We'll just square this current, right? That will be I square, squaring both sides, 3 plus 4 of sine of omega t plus pi by 3, right? So we will square it on both sides. Squaring both sides, we can expand it. It will be 9 plus 16 sine square omega t plus pi by 3. So we can use actually here a plus b whole square, right? Plus 2 into 3 will be 6. 6 into 4, it will be 24 sine of omega t plus pi by 3. Omega t plus pi by 3. So this will be the expansion for this question, right? Now we have calculated the square. Now what we'll do is we'll calculate the mean of this square, right? Mean of this square. So it means that we'll calculate mean square, right? Now we'll just take the mean of each and every term, right? to calculate the mean of this square of the current, right? We'll take the mean of this final term as well. That will be 24 sine of omega t plus pi by 3, right? Now let's remember some of the important results, right? One of the important result is that the average of sine of theta or average of cos of theta for a complete cycle, for a one complete cycle, it's always equal to 0, right? It's always equal to 0. So the average of sine theta, be it sine theta or cos theta, for a complete cycle, it's always equal to 0, right? And similarly, average of sine square theta, right? And cos square theta, it's always equal to 1 by 2 for the complete cycle, right? So these are the two important results which we'll be using to calculate the RMS values, right? So the average of sine theta cos theta is equal to 0 for the complete cycle. Average of sine square theta cos square theta is equal to 1 by 2 for the complete cycle, right? Now 9 is a constant here. Its average value will be 9 as it is. I will just take 16 outside. It's sine square omega t, or we can say it's sine square theta. And we know that average of sine square theta is half. So it will be 1 by 2, right? Plus, and the average of sine of theta here is 0. So average of this term will be nothing. It will be 0, right? So that will be 0, right? We'll be left with uh, 9 plus 8. That will be equal to 17, right? That's 17. Now, we have calculated the mean square value. That's equal to 17, right? At last, we have to just put the root to the mean square value. We'll get the RMS value, right? So we'll just put the root here to this mean square value on both sides. That will be root 17, and this value we call it as IRMS, right? So IRMS value is nothing, it's actually equal to root 17, right? So root 17 is the IRMS value for this particular equation of the current, right? For the particular given current, right? Now let's discuss some of the very important questions with respect to the calculation of the RMS values, right? So let's further discuss one or two questions on the calculation of the RMS values, right? The question is that find out RMS value of following currents, right? We have been given two currents here. One is I is equal to A plus B sine of omega t, and the second is A sine omega t plus B cos omega t. So we'll just what we'll do here, we'll just make the two divide this page into two, right? So we'll just solve this question on this side, right? On the second question on the right hand side, right? So what we'll do here is that we have to calculate RMS value. So first off, we'll do the square of the given function, then we'll take the mean of that square, and then finally put the root on that function. We'll get the RMS value, right? So first of all, what we'll do here, we will square it. So squaring it on both sides,